Hi, we're Team 16 and we created a portable water filtration device. We are a group of 4 engineers from UIC. My name is Tishri Kandakar.
I'm Eric Taylor.
I'm Monak Patel.
And I'm Andrew Solomon.
The main goal of our project was to design a portable and affordable water filtration device that could provide clean water in developing countries and areas where clean water is not readily available. The process of filtering water is extremely complex since there are many factors that need to be considered. Therefore, we did extensive research in order to find a pump and filters that met our requirements for the project.
Our first task was to decide on a circulation and filtering system design. We had 3 to consider: the hand pump and filter, the battery-powered pump and filter, and the gravity filter. We measured these devices by their weight, their flow rate, their waste produced, their production costs, and the quality of water that was produced at the end. Ultimately, we decided that the first design, the hand pump, was the best because of its low weight, its relatively low production costs and waste produced, and its good flow rate produced.
Some of the preliminary design ideas included a backpack design, a briefcase design, and a rolling cart design. Each of the 3 designs include the filter and the water storage inside the actual housing. They also include an attached storage for the pump and the testing strips. The rolling cart design is the one we implemented towards our goal after creating our decision matrix.
So here's the decision matrix for our housing. The design 3 accommodated the weight the best because it was going to weigh a good amount either way because the filters and the water weighed a lot. We also wanted to be durable, portable, cost as little as possible, and may possibly have some storage in case the user wanted. Design 3 did the best in most of the categories except for storage, and that's the design that we chose. It got the best score out of all of them.
So here is the models for the makeup of our final prototype. We were unable to produce an actual prototype due to the effects of the COVID-19 pandemic. At the front, you'll see a little device called the entry grate. This will go into the actual puddle or body of water that we want to pump out of. There is a grate at the front of it so as to block extra debris from damaging the system within. The hoses are made out of rubber, and the water goes through these hoses as well as the pump to the filtering system in the back. The filter system is a 2-step system, and it is attached at the top of the box. In order to clean out the filters, you have to unscrew them from the bottom. Once it goes through the filters, it goes to the jug out in front. Now, both the jug, the hoses, and the pumps are a little bit loose so as to accommodate for extra storage and if you want to move the things wherever you want to. The jug can be pulled out and used as just a normal jug for water. At the top of the jug, there is also a device called the strip holder. This is where the testing strip will go. It'll hang the strip over the top of the jug, and the water goes from the hose over the hole of the jug and onto the strip itself so that you would get a perfect direct line of flow for the test strip.
For validation of design, we decided to use a dual whole house water filter, which contains a sediment and carbon filter that can filter large and small particles as well as remove bad odor and taste. However, they will not remove certain chemicals, which is why the testing strips are incorporated in our design. In addition, the filters have a 5-micron rating, which will meet most of the standards and regulations for water. We decided to use a hand pump because it is a very affordable source of power. Plus, it is easy for the user to operate and requires minimal setup. Lastly, in order to transport the device, we picked a rolling cart design. We noticed that all of our components together were fairly heavy, so the rolling cart will compensate for this.
Many of the parts that are in this prototype were pre-made. However, there were some parts that we designed ourselves. One such part is the entry grate. As you see on the left, the entry grate has three parts, two parts of a holder and the actual grate itself. The holders would have been made out of 3D printed PLA and is a screw top design with a ribbed back. The back allows us to plug it into the actual hose while not falling out easily. The grate, as you can see on the right, was actually produced out of acrylic. We originally wanted it to be metal, however, we were told by the people at the makerspace that this would not be possible because of the curves within the design. As such, it was made out of acrylic. We then measured this design in ANSYS, and we realized that even though there would be some strain on the device, on the grate, it would not be enough to destroy it, and thus it would be able to support potential debris coming into it. Another part that we designed was the actual strip holder. The test strip would have gone through the center rectangular hole there, so it could stick out over the large hole of the jug. In addition, there were two small holes in the back of the holder that would have corresponded to two smaller holes on the jug itself as well. In these holes would have been these two plugs, as seen on the right. These plugs allow us to allow the thing to be held on there. However, they are removable, so if you want the holder not to be on there, you can do so.
Here's our financial analysis for our prototype and what would be 1,000 units. So for our prototype, our total cost came out to be $176.93. But when buying parts in bulk, a lot of the time you get a quantity discount. So we got a quantity discount for the filter and the filter housing, the pump and the tubes, and 3D printing filament is much cheaper when bought in bulk. So there was a significant discount there. We got about a 7% price reduction in total for one unit. So for 1,000 units, our total came out to be $165,691.50. And here we are adding the shipping, handling, and like the labor costs in total. We're doing international shipping, of course, because we're shipping to third world countries primarily. So this is for 1,000 units, just to be clear. So the total came out to be $302,671.50. Here's a quick video of the pump and the filter in action. We did use clean water only because we could not implement the grate that we made, so we didn't want to damage the filters. Right here, I will start pumping real quick. The pump requires very little strength to use, so anybody could use it. It's very easy to use, and it also pumps a very good amount of water pretty fast. You can see that the second filter is already filling up, and very soon water will be coming out. The water comes out at a good force too, very quickly, so it's what we wanted.
And for marketing, the idea for this project was for it to be marketed as a charitable donation, so it could be distributed to people in areas of need. So I researched several companies that could sponsor our project and that we could collaborate in the future, which include the Water Project and Charity Water.
One of the conclusions that we came to at the end of this project was that filtering is a very complex and complicated field of study. Most of the things that we found were usually on the large scale with regards to a centralized plumbing system for some sort of community. However, our device is not for these communities, it is for those that are not as advanced, who do not have these types of problems, these types of systems. However, these systems are necessary for the development of these communities because they promote health and help out the people in there. And this idea will only become more important as water gets more scarce due to the effects of climate change in future.
Lastly, this project would not have been possible without the help of our advisor, Professor Yardemichi, and our acting sponsor, Professor Brown. We are extremely grateful for their support. And special thanks to Makerspace for helping with the fabrication of the grate.
That concludes our project. Thank you for listening.